this session number 368, and today I will try to continue with this problem named count subarrays with a score less than k. It's a hard problem, and I didn't remember. Okay, no, I remember that this solution is a little tricky. Let me check. Let's say, oh no, okay, here. Let me check what I was trying to do it here. I will reset. Reset the format. Sorry. And the score of an array is defined as the product of its sum and its length. For example, the score. Let me check. I don't have any submission. For example, the score of 1, 2, 3, and 4, and 5 is 1 plus 2 plus 3 plus 4 plus 5 multiplied by the length, that in this case is 5, and the result is 75. Yeah. Now, given the integer array nums and integer k, return the number of non-empty subarrays nums whose score is strictly less than k. Subarrays contiguous sequence of the elements, blah blah blah. Whatever. Now, what is happening here? Okay, in this case, let me check what is my my code, because I didn't remember. We have L, air, a counter, accumulator, prep, and calculus. Okay, sum and numbers multiplied by the length. Okay, and we have the length. Iterate over these numbers. Return the number of non-empty arrays. In this case, accumulator plus equal nums in the position air. Yeah, the number. Now, if the calculus, that accumulator multiplied by the length, in this case air less L plus 1, yeah. In this case, for the first number is 2. Now, do you know what? Let me copy this. Use the middle for try to follow what is happening here. Okay, nice. Now we have a test that is this. I will copy and paste here. Oh my gosh. Okay, I think that it's enough with this. And now, okay. Now the next that is the first is initialize this. All the variables in 0. L it's equal 0. Right, it's equal it's equal 0. Counter it's equal 0. Cum it's equal 0. And prep it's equal 0. And calculus it's equal 0 too. Okay, and we start in this case with the 2. Let me increase this. Perfect. Now we start with the first. In this case, the accumulator is plus equal is 0 plus air, that in this case air is equal 1. 0, sorry. Is the first number basically. This, the 2. Okay, we have 2. Multiply by 0, the 0 is 0 plus 1 is 1. 2 plus 1 is 2. Okay, this accumulator. Accumulator is greater, 2 is greater equal that k, that is 10. No, okay. Calculus is minor that k, yeah, in this case you need count. I remember. I think it's because I forget to count the single numbers, but let me check. Counter. Okay, now counter. Where is counter? Counter. I think that is this. Is one. Now is one. Okay. Got it. Now this is done. Yeah. Now the next step is this. Accumulator plus equal accumulator plus equal accumulator have the value of 2 plus equal nums in the position R, that is 1 plus 1 is 3. Yeah, and 3 multiplied by 2 is 6. Yeah, in this case is 6. Now 6 is greater equal k. No, in this case r minor. In this case I think that always is true, because for this reason I have this, but well, let me check. Counter plus plus. Okay, we have counter, we have another, and move to the next. The next is this. Okay, now the next that is the 4. Accumulator plus equal accumulator is plus 4, it's equal 7. Okay, calculus, it's equal 7 multiplied by 3 is 21. Okay, here is 21. Now 21 is greater equal to 10. Yeah, and L is minor than R. Yeah, in this case I will execute this, and the first is that accumulator, that is this. I need to remove the L is this, remove 2. In this case is less 2, it's equal 5. Okay, calculus is equal accumulator, that is 5 multiplied by in this case is only 2. No, it's 3. Here is the size is 3 because it's 0, 1, 2, and it's basically 2 less 0 plus 1, it's equal 3. Here I need reducing 1 because I am doing this, or move this in this position. Yeah, I think that is for this. L plus plus, and next to apply the calculus. Okay, in this case, do you imagine that I fix it? Even let me put here this one. Yeah, in this case, for example, the calculus is accumulator, that is 5 multiplied by 2. In this case is 10. Calculus have the, now the new value is 10, and L plus plus. L now is here. Come on. Yeah, and calculus is still greater equal, in this case equal to k, that means 10 and 10. Yeah, okay, execute again. Accumulator minor equal L, that is 1. In this case it is changed to 4, and we need 4 multiply by 1. Yeah, only this, because in this case L plus plus. Yeah, in this case is 4 multiplied by 1 is 4. Okay, now accumulator calculus have the value of 4. And it's broke this cycle, and now 4 it's minor than k. Yeah, okay, now increasing 1. Yeah, and L it's here. No, yeah, L reached the this is L. Now we can continue with the next, that is the 3. In this case, accum plus 3, it's equal, it's a 7. 7 multiplied by a 2, it's equal to 14. 14 is greater equal to 10. In this case, yeah, means that accumulator that is 7 minor equal the position of L that is 4. In this case, this come on, change to 3 because it's 7 less 4 is equal to 3, and now it's multiplied in this appear here, and now it's multiplied 3 by multiplied by 2. In this case is 3. Yeah, and this is broke, and now counter increase in 1. 4, we have 4. Now the next okay, now sorry. Now the next that is we are here. Now the next that is the last. In this case is this 5, and is accum plus 5. It's equal 8. Okay. In this case, this is 8. 8 multiplied by 2, it's equal 16. 16 is greater than 10. Accumulator minor equal, in this case 3, it change to 5. Yeah, and okay, maybe it's for this. Change to 5, and now the new calculus is 10. Here is 10, and L reach this. And now it's broke because both are in the same. Yeah, and in this case, no, this is wrong. This is 5. And now here is 1, 1, 2, 3, 4, 5. And how many? I have 5. And no, it's not this, it's this. But it's 6. Why 6? I think that I am losing one calculus here, but I don't see. I think that one is this, another is this, only this, another is this, another is this, and another is this. Yeah, this is the only number that is still alone. Yeah, because in this case, for example, I think that, oh no. Where is okay. For example, here I think that the execution is basically take this and add 1, move to the next, and add 1, move to the next, and in this case I need to remove this, and I lose this. I think that we need count this number itself. You know, here for example, counter. Well, the first point is that this always is true because for the reason I have the this while, but in this case it's basically if plus equal, in this case nums in the position r it's minor that k, then one, sorry, other case at 0 for output 10y, it's minor that k. Okay, in here I think that I can conditional the cases where the length is equal 1 I counted before. If L is equal R, it's different. Are different. Yeah, here basically I am counting all the numbers that are minor that k for count itself. Yeah, for example, in this case the only number is this. All numbers are minor that k means that at least we have 5, 1, 2, 3, 4, 5 elements that are subarrays. Yeah, and in this case is for example here this and this are equal. When reach this is 2 plus 1 is 3 plus 4 is 7 plus but multiplied by 3 is 21. 21 is greater equal to this. Yeah, in this case uh, 21 is greater than k. Yeah, L and L it's minor than R. Accumulator minor equal the first position and L plus plus. In this case I am trying to calculate in which moment the Subarray is greater than k. Individual subarray one slot. Yeah, and for the others is calculus. For example, if I take this, is the calculus is 21. 21 is rated at 10. Yeah, we reduce the 1, the 2, sorry, and only we have 1 plus 4 is 5 multiplied by 2 is equal 10, is still greater, equal that case, that means that have the value 10. Now the next stat is 10 is greater or equal 10, yeah, accumulator again, this is moved to this, and is accumulator 5 less 1 is 4, L plus plus, and here is 4 multiplied by 1 is 4, in this case is broke. L and R are different, in this case are equal, because I reach L is start here and R is here. I need to remove this and I need to remove this. In this case both are equal. Why is counting here? This case, let me check. In this case is the first iteration. The first iteration is this is okay. The first and the second iteration it's okay. Now the next stat is this. In this case the calculus is 21. And we need iterate. And now calculus is 5. Why is 5? Okay, I am wrong here. Why is 5? Counter is equal 4. Accumulator is this. But should we have four? Okay, no. Let me check again. What is happening here? Okay, first time. Second, here, 21. Okay, and accumulator have 7, yeah, because it's 2 plus this is 7. And the calculus 7 multiplied by 3 is 21. Okay, now the next stat is we need to take the first position, the position of L that is 0, and reduce the accumulator. In this case, should we have 5 at this moment? L plus plus, I think that is for this. L plus plus, and now calculus it's equal 5 by 2, it's equal 10. That is still true and conditional. Now accumulate. But this is for this. Why? 5 or whatever, calculus. In this case, accumulator calculus is 5. How can I be 5 if we don't have any element with this value? I am wrong in this. I am wrong here in the while. Why is 5? I am calculus wrong because it's starting the first is 7. Until this point is 7. Okay, got it. Now when entry accumulator is reduced, increasing L. In calculus is the accumulator. Let me check what is wrong here. Okay, here calculus is we only have this, okay? Now the accumulator that have this, we need remove the first element. In this case, I remove it, increase L, and the new calculus. The calculus is 2 less 1, it's 1. Okay, here is plus 1. Okay. Let me check if we have a few tests. Oh, this should be medium. Come on, but any test. Okay, I will submit. Okay, I have this error. What is the result? 13. And I 11. Okay, the first. I think that is because maybe this is wrong. I will comment. I need change this approach also. Calculus is gray there. Yeah, but in this case, because for example, in this specific case 214, the first element I need to resolve this. Here, for example, is 2 plus 1 plus 4, it's equal 7. Yeah, with this we don't have problem because we have 1, 2 subarrays. Yeah, that is this 1. No, sorry, it's 1 and 2, but here should we have 3 because this itself it's another subarray. Okay, but in this case my code only detect this. Okay, we have 2. Now we have this, and when basically I reduce, this is all the subarray is starting remove the first position, this, and still greater, or in this case is equal to 10. Yeah, and remove this, and only we have 4. But I am losing this element. I'm not sure if I need to have like this. Okay, the 2 is the first subarray. Got it. Now the next that is 2 and 1. Sorry, and 1. This is another subarray, and it's okay. Now where appear this before they apply the zoom and whatever, try to reduce this and move to the next. For calculus this, if I don't know. Maybe it's this way. Yeah, detect. Okay, if adding this number is greater than our current target, that is 10. Yeah, try to apply the sliding windows over this. No. Okay, let me check if I have a few hints. Hint 1. If we add an element of the if we add an element to a list of elements, how will the score change? Don't have any sense to me this comment. How can I get use this to determine the number of Subarrays scores? You know what? I think that I think that we can start this, and obviously this is minor than 10, and we need calculus. Is the length? Yeah, basically it's the length. Means that we have only one array here. Now for the next is with the 1. In this case the result is 2 plus 1, 3 by 2, it's equal 6. 6 is still minor, and the length is 2, means that we have 2 possible solutions more. 1. And for example, when reach this, in this case is 2 plus 1 plus 4, it's equal 7, multiplied by 2, it's equal 14. In this case we need to remove 1, that this, and only we have this, but it's still greater. Now, yeah, I think that this is the solution. For calculus, the individual position is basically for the length. Accumulator, blah blah blah, calculus, in here is here. Counter plus equal, in this case is plus equal R less L plus 1 is the size of the elements. Okay, now I think that I am repeating something. Let me check. Accumulator plus equal counter plus equal the length, in this case 3 and 15. Here I need calculus the subarray, but what is wrong here? I will copy again. I paste here. And whoa. Let's here. Okay, now in this case okay, now the next that is okay, we start. Let me increase this a little bit. Okay, much better. Nice. Now we start with the first that the accumulator accum it's equal to calculus is calculus. It's equal to, because it's 2 multiplied by 1, it's only 2. 2 is greater than k, no, in this case counter plus equal, counter, it's equal r. I see my error. Is this. Come on. Okay, I'm near, or I close to the solution, but what is happening here? It's for the longs. It's for the long. I think that is in the calculus. The calculus should be calculus accumulator. I think that long. Yeah, it's for the longs. Come on. Why? What is the error? Okay, counter. I changed all for prep. What is prep? Prep is not using anymore. Finally. Okay, it's not bad. I think that I can improve, but it's a solution. Solution using sliding. This is sliding. Windows. Java. Well, I think that compared with the other hearts problem, I think that this is easily. I think that for the reason that people say that is a medium problem. This is wrong. It's only counter because counter is a long. Yeah, and here now I will publish in my account. And now, oh, this is wrong. I have to only a few hard problems solved. 10? Okay. I need to increase too much this number, at least 100. But well, I will check the other solutions. This. What the? A 4 and while. Okay, let me study this solution. I paste here. I copy. And okay, what is happening here? Sum and res is equal 0, and basically it's transversal. Why j? I don't understand why put the j here and don't only create the variables in this line, but well, or in the next line, but whatever. Okay, it's only transversal. Now sum plus equal nums in the position I, that is L. I think that I is L and J is R. And now is sum multiplied by I less J plus 1 is greater than K. But in this case, how? Sum plus J plus sum less equals nums in the position J. No, in this case L it's R, L is R, sorry. I is R and J is L. Yeah, for example, if I do this, basically is calculus. In this case, this is not necessary, but in my case, I will get. No. Oh, okay. And now is L plus plus. I think that we can avoid this and only accumulator plus equal this, and this calculus do it here. Yeah, and yeah, this is compressed solution. And now this is not necessary because it's doing in the top. And counter it's equal this. Calculus is done. counter is okay, and yeah, I think that it's the same. Let me check if improve a little bit, but in essential is the same. In essential, not essential. Essential. Submissions, 2 milliseconds. Well, it's a little bit more. Is this? I think that is only the calculus, but it's more faster, only for 1 millisecond. Okay, in this case, let me leave one note to myself. Don't forget that calculus individual elements are calculate by the length. In this case, for example, 1 and 2, 1 and 2, the sum, and multiply are minor than k, but the possible subarrays are 1, 2, 3. Are 3. Sorry, are 2. This and this. And okay. Only that. Well, I think that it's enough for today. Thanks for following this transmission, and I hope see you in the next. Bye bye.